Thank you everyone for joining us today for our second Power Hour series in the fall here. My name is Blake Bonham. I'm the sales engineer over here in Eastern Washington, Spokane, and I'm joined by three other sales engineers over in Seattle. We got Scott Boucher, Chris Woldridge, and Nick Andrews. We have a great support staff here for Dorsey. And we are joined by Jay Afferbecker. He's been with Greenheck for 27 years. We're lucky to have him. He knows all things eCAPS, the powers of eCAPS, and he's got a good presentation and some useful tools that some of you may or may not know about, including our Revit add-in. A couple housekeeping rules. I'll just mute. Everyone's muted. So if you have a question, enter it into the chat and we'll answer it on the spot, or if timing's right, we'll answer it at the end. Really excited. eCAPS, great software. Jay, I will have you introduce yourself and we can just get it going. So thank you everyone for joining, and Jay, off to you.
All right. Well, thank you, Blake. Welcome everyone. My name is Jay Hofferbecker. I'm with Greenheck up in Wisconsin, mechanical engineer. I've been with Greenheck 27 years, as Blake had mentioned. Worn a few different hats in the company, and currently I work with our selection software, eCAPS, Revit add-in, BIM and Revit Content, and our engineering version of CAPS as well. I mean, ultimately, my goal, or what I'm tasked with here over the last, quite a few years, is to basically work with the engineering community on how to be more efficient in that design process. So the guys at Dorsey there asked me to come in and give you guys a little prezo on hopefully making you more efficient in that design process. So what I've got here for an agenda for the next 45 to 50 minutes here is I thought we'd touch on a real quick BIM and Revit overview related to like this terminology LOD. And then I thought we'd compare and contrast some of our selection software, eCAPS and CAPS, to figure out which one maybe you should be using. And then maybe run through an eCAPS demonstration, hopefully show you some tips and tricks in there and show you how to use the program the way it's intended, and then also follow up with a Revit add-in. And again, as Blake had mentioned, if you've got any questions along the way, just type them in the chat and we'll address them. All right, so let's get started. I assume that many of you are using Revit to do much of your drafting. And one of the things I wanted to touch on here is this term called LOD. It stands for level of development, okay? And the American Institute of Architects came up with these LOD levels 100 through 500. And you're probably designing to one of these levels, right? Your architect or building owner or whatever is saying, hey, we need an LOD 200 or 300 or 350 or whatever the level is, right? And the reason why I want to spend a few minutes on this is, we at Greenheck, we offer multiple LOD levels of our manufactured content. Okay. And if you're designing to, a different level than what you're getting the content from us at, you're either, being underprovided and you have to spend some extra time supplementing that information, or you might be over that and you might be at a liability. So real quickly, let's just kind of run through each one of these LOD levels and I'll kind of talk about what the differences are here. So the first one here is the LOD 100, typically used by architects in that pre-design stage, laying out the building and the different spaces within the building, right? Not very helpful yet from our perspective, an HVAC perspective. But then there's the LOD 200. Engineers get involved with this one on that schematic design phase. Now we're saying, well, how much air do we need to ventilate in this space? Typically dictated by an air changeout requirement. What size of the ductwork? That's about as far as we go with the LOD 200s. But then you get into the 300s, and now we're in that design development phase, right? Now we're making selections of products, we're creating schedules of equipment, we're doing electrical coordination. A lot of that stuff happens here at that 300 level. And then there's the 350 level in that construction documentation phase, right? Design build contractors fit into this, design assist engineers fit into this as well. Now it's not just, what's the product that we're, putting on this project. But now how does it interact with the rest of the building? Do we have vibration isolation? Is it a flange connection or a collared connection? If we do have vibration isolation, is it 1 inch deflection or 2 inch deflection or what, right? That's where the 350 level comes in. And duct hangers kind of fit into that arena as well because we're designing for construction, right? Then there's the 400, typically reserved for the contractors only, right? We're actually fabricating things. We're maybe building sub-assemblies back at the shop, sending them to the job site for field assembly. The different disciplines, clash detections already, happened at that point, and so on, right? And then there's the 500s. The 500s are the as-built. At this point, the building's already been built. Someone hires a third party to come in and update the Revit project to how it actually got built, add supplemental info like serial numbers of the products that got installed, replacement parts list, maintenance schedules, that type of stuff. Okay. Um, we offer content in the 200, the 300, and the 350. Okay. And this slide here represents, well, where would I go for these different LOD levels? So the first one there, if you go to greenheck.com, you're going to get an LOD 200, what your typical, HVAC manufacturer offers, just, basically a Revit family. You download it off their website, and you pick a size and you insert it, away you go. No performance, no electrical info, just the 3D space envelope of the product. Now, if you use our eCAPS program or our Revit add-in, well, now we have access to our LOD 300. That includes, a lot of the parameters for scheduling, performance information, electrical information. That's all in there, right? If you're entering that information into eCAPS or the Revit add-in to make a selection, why wouldn't we include that, right? So that's where the LOD 300 comes in. And then the 350, you'd get that from our downloadable or desktop CAPS program, or the guys at Dorse can get you copies of that content as well. Okay. All right. Any questions related to the various LODs and kind of what we offer there at this point before I move on to the next step? Let's go ahead and type it into the chat, and if not, I'm going to proceed. All right, so next let's switch gears and talk about our selection software. Now you can have the guys at Dorsey, make selections for you, or you can choose from one of two programs and make selections on your own. We offer an eCAPS program and a CAPS program. This slide here is kind of to compare and contrast the difference between the two different selection programs, right? So the eCAPS program is really designed around the typical engineer's workflow. And what is that? Make selections of products, but ultimately populate a schedule of equipment for the contractor to purchase and install, right? Knowing that we made it simple, fast, and intuitive, just enough information to populate that schedule. And along the way, maybe you want to download a cut sheet, or maybe you want to download a drawing or do some comparisons and stuff of that nature. That's all in there. It's an online tool, nothing to update. It's all, it's always up to date, right? So you just gotta run the website. We optimize your selections. I'll give you some examples of what that means, but we're going to guide you towards the best value product. We'll also steer you away from some of the troublesome selections. We've all got quite a large offering of HVAC equipment, and there's the good and the bad based upon your performance point and a lot of other things. So, we're going to steer you away from there to make sure you got a good, stable selection on test and balance day. And it's got our core products in there, as you can see, and it also integrates with our Revit add-in as well. Now, to contrast that to CAPS, which is a desktop program that's installed on your computer, right? That's really designed around the local mechanical rep like Dorsey, right? They use that program day in and day out, all day long, probably, right? And that's got all the bells and whistles in it. Some of the I don't want to use the word oddballs, but some of your specialty products are in there as well. A lot of special, maybe one-off options and accessories are all in there as well. It's a great program. You got, basically all your advanced selections, but it doesn't give the guidance that eCAPS does, right? It is an install program, so you have to have admin rights to install it and update it. It's got all of our products in it, including kitchen hoods, but kitchen hoods can get pretty complex. I'd probably get a hold of the Dorse guys and they can help you make those selections. And it's got a little bit higher level of drafting detail. Now, at an ultra high level, you're wondering, well, which one should I be using? And I typically say if you're a plan spec type engineer or you're somewhat newer to the industry, you're not real familiar with our model names, or you just want to be guided and do something really quick, eCAPS is definitely the program to use. If you're a design build contractor or you really like to get into the nuts and bolts and you really know your stuff, then maybe the desktop CAPS program might be the better program to use. And you can make an eCAPS selection and send it to CAPS. You could use either program or both. There's no right, no wrong there. They're both going to be available for a while yet. But that's kind of the difference between the two. Now, I understand we primarily got engineers on the call here, so I'm going to focus on our eCAPS program. This is my last PowerPoint slide. Greenheck's got quite a product offering, right? Just from a fan's point of view, we have over 10,000 different models and sizes of fans to pick from. Wow, I mean, 10,000 of it. Think about that. And there's a reason for every one of those 10,000 selections. But at the same time, that can be real overwhelming. Well, geez, which one do I pick, when, where, and why? Well, that's kind of where eCAPS comes in. So envision that triangle you see on the screen there being a funnel. Okay, and at the top of that funnel is our product offering, right? Those 10,000 selections. And what we do is we ask you just the right questions along the way, like what's your application, what's your performance, then we're going to optimize it. We're going to do a stability check, and then we're going to make our best value recommendation for you. So that's really what eCAPS does, and kind of think about that as we're running through the demonstration of it. I'm going to probably focus a lot on fans, but we're much bigger than just a fan company. We got a lot of other louvers and dedicated outdoor air systems and makeup air and energy recovery and lots of other stuff as well. And it all kind of follows that same process. I just use fans as the demonstration. All right, so with all that being said, I'm going to shift gears here a little bit, and we're going to fire up eCAPS and run through it. For those of you that don't have eCAPS, you just type in the website address ecaps.greenheck.com. You do a Google search for it. You go to a greenheck.com website, and search for the software, and they're all going to bring you back to this point. Okay. You don't need to log in. You don't need an account to use the program. There are advantages of being logged in, like you can save your jobs and reference them later. It saves some of your screen presets or customizations, and you can also share your projects with others, all of which we'll kind of talk about as we're going through it. So there are advantages to being logged in. All right, so this is the main screen. You'll notice that some of these groupings here have a little Excel icon in the upper right-hand corner. What that means is that I can make selections of those product types, and I can create an Excel schedule, as an output, right? And I'll show you how to do that. The products that don't have it, you can still you can make selections. There's more of like a guide to guide you towards, what products to use. And it's got links in there for downloadable drawings and, more generic cut sheets and, stuff of that nature as well. Okay. All right. So let's just focus on a fan. We got subcategories here. Maybe I'm looking for a roof exhaust or a roof supply or maybe an inline fan. Let's just do inline. And so then we got to enter in some performance, right? So I'm going to enter in something random here. I'm going to probably enter in like maybe 5,000 CFM at like 2 inches of pressure at sea level. I'll pick my voltage cycle phase, maybe 460 volt, for example. So it's running through a couple thousand selections right now, and it returned 43 different fans that all meet that performance. Okay. Now, as a general rule of thumb, pretty much all fans can be used for general clean air applications, but some fans can have provisions on them for other applications, such as emergency smoke control or high wind rated or a seismic rate requirement you're working on a hospital or something, or I'm using for restaurant exhaust, or I got a spark construction level that I need, or outdoor use. I'm not going to read them all off, but you get the idea. And what that does is you don't have to know the model names. You pick your application, and it'll narrow your list of models that are and or sizes that are available to satisfy that, right? So that's going to narrow our selections down. All right, you'll notice, within these 43 selections, we got a comparison option here. Maybe I want to compare this one to this one to this one, for example, and an image of the three could pop up. We got the intended application. We've got the space envelope here. It's my overall length, width, and height, for example. Maybe I'm trying to mount this fan above a ceiling or something, and I've got only 24 inches to work with. Well, you can see that the only one that's going to fit physically might be this AX, for example. We got fan curve comparisons here. We got sound chart comparisons by octave bands. Some fans octave bands are easier to attenuate than others, so that kind of goes by octave band. And then we also got the construction features. And I picked these three fans very deliberately. Notice that the wheel types here are very different. Right, so this first little SQ here that uses a mixed flow style wheel. The next one uses a centrifugal backward incline style wheel. And the third one uses like an axial or propeller style wheel. And many of you might have had a fan fundamentals along the way and, learned, hey, centrifugal fans are great for, higher pressures and axial is great for higher volumes and stuff of that nature. And that's all really good stuff to know, but at the same time, some of those fans kind of cross or overlap, right? So what we're doing in eCAPS is we're evaluating all the different wheel types. Okay, and that's in this list of 43 different selections. And then what we do is we talked about the optimization part of it, right? So rather than the first selection being maybe the least cost or the smallest physical size, stuff of that nature, what we do is we rank our selections, okay? And what we do with that is that's where that best value piece comes in. It's that delicate balance between a great performing unit and low cost. Okay, so it's kind of a balance, right? So we got a bunch of algorithms behind the scenes there that are doing a bunch of math to try to optimize and do the best ranking, right? And so what's our secret sauce for that? So what we do when we talk about great performing units, we use a component of efficiency, best measured by the lower operating power, right? Ultimately driving to a lower operating cost, right? And it kind of has an FEI built into it. So those are kind of all related to your efficiency. And then addition to that, what we do is we add a component of sound because, who doesn't want a quiet fan on operation day? Want to make sure our tenants are satisfied, right? So we bring in the sound component and then we offset that with the budget price. Our budget price is just a rough number of HVAC dollars in the system. If you want an actual price quote based upon the, all the bells and whistles and lead time and everything else, get a hold of the guys at Dorse and they'll get you a price quote. But this budget prices to get you in the ballpark. Is this a $5,000 fan or a $50,000 fan, right? That's the intent there. All right, so let's analyze this ranking just a little bit more. So if we take a look here, these half dozen top ranked items, or even the first 10, for example, kind of hover around that $5,000 price point, right? And as we dig deeper in the list, meaning less recommended, you'll notice that price typically goes up. It might be a larger diameter fan than you really need, or maybe a heavier constructed, material gauges or wheel designs or whatever that you might not need for that particular performance and application. So that's kind of where that ranking helps out. Now, if we would microanalyze these top half dozen ranked items, you'll notice that the first item is not necessarily the least expensive fan. This one here that's ranked number 6 happens to be the least expensive fan. And if we take a look at that one, you notice that by going from the least expensive fan to what we're recommending as the top ranked fan, it's roughly $400 more, right? And so if we look at that, you can see the least expensive fan is roughly 3.9 brake horsepower. The top one is 3.1, so that's almost a full horsepower. And they both use a 5 horsepower motor, but you can notice that your operating cost is a couple $100 difference. So in this theory, it looks like about a year and a half you're going to pay that one off. It just from a purely dollars perspective. But there's more to it than that. What about the sound? Well, we went from 45 sones or 85 dBA down to 22 sones. That's almost half the sound. That's enough to matter, right? So that's kind of that what we're talking about with the ranking. We would recommend any of these top half dozen ranked items over any of the bottom ranked items, all day long, right? But that's not my choice to make. That's your choice to make. We're just trying to guide you towards, some of these better selections. In addition to that, we added some more tools in here. Maybe you want to filter on something and say, well, geez, I need an FEI of at least 1.0, so that takes me from 43 selections down to one. Maybe I don't want a 5 horsepower motor. I want a three on this thing, and I don't want my sound to exceed, 20 zones or something of that nature. Let's make that just a little bit tighter, maybe 18 or something. I don't know. And then I don't want to spend maybe more than, whatever, $10,000 because this is a price sensitive job or something of that nature, right? You can see that, oh, hey, the QEI 18, 20 and 20, looks like 16 all meet those requirements. And my best one of the three is really the QEI 18. That's a good balance between all the stuff. So that's kind of some neat tools that we built into the program. If we want to know more information about this QEI, we click on it. We've got a better description on it. We've got the actual fan curve here. We can also, excuse me, we can also look at the min-max speeds, RPM families, that type of stuff. We can look at the dimensions. We got our space envelope and connection sizes. And we also have downloadable drawings in a 2D AutoCAD, a 3D AutoCAD, and Revit content in both the 200 and the 300 LOD. And we also, we can generate cut sheets from here as well. We have a scenario here where maybe I'm looking at these drawings and maybe you're doing the selections and someone else is doing the drafting and you want to send the drafter the drawings. You can hit the email all button there. It'll wrap up all the different file formats and then you can send that off to the drafter and they can pick whatever one they want and draft with it. So there's some neat features that not everyone's aware of. All right, so one other thing that I wanted to talk about, we're almost at the peak or that point of the funnel that we were talking about earlier, right? And so notice that in this case, we've got 43 optimized fans. Okay, notice the word optimized. I want to stress that a little bit. So, we talked about having 10,000 different models and sizes to pick from, right? And some of those might not be the best ones to use, right? So what we've done is we've hidden some of those selections that are probably something that you might normally maybe use, but are not necessarily the best selections. And we hid those. But if you want to see all of the selections, what we do is we come underneath available sizes and go to all, and we're going to see something more than 43 selections here. In this case, we see 62, so roughly 20 more selections. But now you'll notice that there's some caution icons next to some of these selections, okay? And what that means is there's something to be concerned about with those that are cautioned. And if you want to know what our concern is if you click on it, it'll tell you. In this case, it says my operating curve is within 12% of the maximum system curve. This one here is specifically almost right on at 2%, right? If you want to take a look at that fan curve, you can take a look at it as well. We got a little link there. I'm sure many of you know how to read fan curves, but basically, if your operating point, aka that little circle there, if that happens to be in that gray region, that's unstable. Okay, you don't want to have an operating point in that area. You've got vibration, you've got unstable conditions, small change in static pressure can be a big change in volume. You can get hunting, vibration, all sorts of stuff that can happen there. We won't even allow you to make that selection. It won't even show up in the list over here on the left-hand side to choose from. But rather than just throwing a line on there, what we did is we put a tolerance on there of about 12%. That brings you out to about where my cursor is. If you're operating anywhere from that line, the gray region, down to about where my cursor is, we're going to caution you on that selection. You can still have it if you want it, but just at least be concerned or be aware that, hey, this thing's getting close to being unstable, right? So since we get 10,000 selections, we hid that one by default. That is one potential trigger of 7 for a caution icon, right? So the first one is if your fan curve's maxed out. The next one deals with your wheel. If your operating RPM of the wheels within 5% of the maximum speed of that wheel, will caution you on that selection and hide it. The next one deals with the motor sizing. If your brake horsepower is within 10% of the max motor size, we'll caution you on that one. The next one gets into ratios. If you're running this thing on a VFD, for example, and your operating hertz is less than, I think it's 30 hertz or something of that nature, we'll caution you on that one. And the idea there is, well, the temperature of the motor might get a little bit warmer, the temperature of the VFD might get a little bit warmer, there might not be enough airflow going over the motor to keep it cool. If we got 10,000 selections, pick a different one. And then there's lots of other ones in there as well. But the whole idea there is we're trying to keep you out of trouble, make sure you got a good, stable selection and kind of programmatically, set you up for success. All right. So I thought I'd mention that. Now, if we go back, we were looking at that QEI, I think it was an 18 or something like that before, right? If this is the item I want and I want to add this to our schedule, we simply hit the add button. So if you remember, our ultimate goal of eCAPS is to help you schedule our products, right? So I hit the add button, I need to tag it, right? So in this case, maybe it's inline fan -1. I got some optional info there if I want to, but ultimately when I'm done, I hit the add to schedule button and it's adding it to our schedule right now. You'll notice in the upper left hand corner there, it shows that we've got one item in our schedule. Um, so that's there for us. Now, if we want to add more items to the schedule, we can do one of several things. We can either hit this little plus icon here, or if we don't know what the plus icon means, hit this little thing here and it tells you what these different things are. Or I can use the breadcrumb trail up here and go back one screen or multiple screens and start over. I still got the one item in my schedule. Now, if I want to go see my schedule, I click on it, and that's going to take me to my schedule. Now, for those of you that are scheduling using Excel, this next part here that I'm going to cover is really important. For those of you that are scheduling out of Revit, I'm going to show you 3 different techniques to use that are within our Revit add-in itself. All right, so first let's cover the Excel scheduling. So the first thing is you probably have your own schedule layout at each one of your firms, right? A certain number of columns in a certain order and named a certain way, right? So the first thing we want to do is come over here to our column chooser and we want to select the columns that are in your schedule. Okay, now we default to what we thought were the 10 most common columns, but everyone's schedule is a little bit different, so you can tweak that. So maybe I want to show the full load amps and I don't want to show drive type. Then we come over here and we arrange the order at which you want them in. Maybe I want all my electrical information next to each other, so I drag and drop that. And when I'm done, I hit the OK button and notice I rearranged them. Now, other things you typically see on a schedule are going to be schedule notes, or some people call them remarks, right? What we've got down below here is our library of schedule notes, okay? This is a pre-canned list of 10 notes, but you can add your own custom notes, right? So for example, maybe I've got a VFD rated motor as one of my schedule notes, so we can add that in there, right? And we can add, I think, up to 40 or 50 different notes. Okay, now that's our library of notes. We haven't actually scheduled any yet. Okay, so in this case, we got this QEI. It's an inline fan, so maybe we want to add a disconnect switch and maybe that VFD rated motor and some vibration isolation, for example. So we go ahead and click that, and notice now we've got notes number 4, 10, and 11. I'm going to save this job. I'll just save it out to test. This is the value of being logged in. If you arrange your columns on your schedule here, it'll remember that the next time you come. If you add your library of notes, it'll remember that as well. And if you save your job, it's obviously you can access that anywhere that when you're logged in. All right, so we're focused on scheduling, right? So we're going to come over here and we're going to download our schedule. So what it's doing right now is it's creating an Excel schedule based upon the format that we specified. So here is our schedule. And notice that we added the FLA column and we've got our notes and we got our definition of the notes. Okay. Now keep in mind it renumbered the notes because who's going to actually skip a number in their actual final schedule. So we programmatically did that. Now keep in mind we've only got one fan on this job, but if we had 5, 10, or 15, they'd all be filled up in the list, right? In addition to that, we focused on fans so far. We've got a separate schedule layout for gravity with its own set of columns and schedule notes because those are typically different schedules, right? We also have one for louvers. Our outdoor air products are also called dedicated outdoor air systems. Our high volume, low speed fans, our makeup air, and our energy recovery. Now, we didn't make any selections of those products, so there's nothing filled in here. You know, like the fans has got that one fan there, right? But if I did have some and then I downloaded the Excel schedule, basically it's going to be a different sheet or a tab across the bottom of that Excel file, and you can, copy paste those into your, your main Excel schedule or whatever. Okay. All right. So that's how to schedule for those that are using Excel. Now, a couple other things that we can do here at this timing point. Maybe I want to share this job. Maybe I want to send this job over to Blake or over to Chris for review. What we would do is we'd hit this little share button here and we type in their email address. And we'd say, hey, please give me a price quote and availability, or please review my selections or whatever, and then hit the send button. And whoever you send that to is going to get a copy of that job. Okay, now the recipient of that job, they can do one of two things. They can either open it up in eCAPS and take a look at it and bring it into their own account, or they could open up in the desktop CAPS program. Okay, it's one direction, and when you bring it into CAPS, it doesn't go back to eCAPS. Another little fine point there is it's when you're sharing those jobs, it's always a copy of the original. So if you want to share that job back to the person that sent it to you, you need to literally share it back to them, and then they can bring it back into their account. Okay. All right. So those are some hopefully some little tips and tricks out of the eCAP side of things. If you guys got any questions about how to make fan selections at this point, go ahead and type them into your chat, and we can hopefully answer those questions. Okay, let's circle back to a couple of those here in a little bit. All right, so the next thing I want to do is I want to focus on our toolbox over here. Okay, now we've done all about about doing selections, right? But over here on the right-hand side, we got this toolbox. Now this toolbox is specific to whatever category of product that I'm on. So right now I'm not on a specific category, so it's fairly generic. How to create a schedule, basically what I just showed you, how to make some other good selections and other things are all there, right? But if I go into fans, for example, now notice my toolbox changes. That's specifically related to fans. And one that I like to highlight is our system effects simulator. When we test our fans back here in Schofield, Wisconsin, we test them underneath ideal installation conditions. And what does that mean? Nice, smooth, straight flow of ductwork in and out of the fan, right? And they always get installed that way. Well, I mean, most of you are like, yeah, we design it that way, of course, but sometimes there's a wall obstruction or a building support obstruction or something of that nature that's obstructing that, and or the contractor puts in an elbow where it's not supposed to be or something of that nature. And what happens is we got system effects, right? Effects of the system on the fan, therefore the fan doesn't perform very well. And many of you might have had a class on that, or fan fundamentals or something that covered that, and that's all great. But at the same time, well, how bad is it really going to be? Well, that's where the simulator comes in. Okay, so let's check this thing out. So the first thing we had to do over here on the left-hand side is we got to pick what product category are we working with. Are we working with an inline fan or a vane axial, roof exhaust, or maybe a blower, right? And so we'll pick a blower. And the reason why you've got to pick the categories, the math under the covers is different for each one of these categories. So we got a blower. Okay, and now notice we have no inlet conditions selected initially, and we can select from ductwork to elbows to a wall obstruction. On the outlet, we've got nothing selected, and we can select from ductwork and elbows as well. So I'm going to come over here, and I'm just going to pick a sharp elbow and put that immediately at the inlet of the fan. So basically, the air is coming from up above, and it's taking a 90-degree angle, and it's going right into the inlet of the fan. Okay, that's bad, right? But how bad is it? Give me a number, okay? So if we look over here on the right-hand side, we can see it's going to have a 7% impact on the volume metric flow rate, your CFM, right? So if you're short on air by 7% on test and balance day, what's the solution? Well, the typical solution is speed it up, right? I'm not suggesting that's the best solution, but that's the easy button solution, right? So if you're short by air by 7%, what do you got to do? You got to increase your RPM by 7%. Using that first fan law, right? Your RPM and CFM are directly proportional. So you swap out the belt and pulley combination as a belt drive fan, or you turn up your VFD if you have a VFD on it and move on, right? Yeah, but not so fast. Okay, what happens to your brake horsepower requirement as you increase that speed? Well, that goes up as the cube of those RPM ratios, right? In this case, it goes up by 23%. We only increase the RPM by 7% to try to get 7% more CFM, but your brake horsepower required to do that or achieve it is 23% higher. Now, you probably don't have enough motor to spin the wheel that fast because, most people don't oversize the motor by 23%, right? So you can't even get there without swapping out the motor, maybe even swapping out the size. That's why system effects are so detrimental to the system. So, fine and dandy, Jay, but what do we do with this now? What are some use cases? So there's two big use cases that I see for the system effects simulator. The first one is if you're working with the building owner or the architect and, hey, I need an extra 3 feet of straight ductwork in the system, in my utility closet, for example, in order to get, achieve best performance. And what you can do is you can print this thing out. There's a print button up here. And basically it'll show you kind of the summary of what's on the page there. But you can have that conversation. If we don't get those extra 3 feet from my utility closet for that straight ductwork, we're going to have a 23% increase in the power consumption for the entire life of that fan. Now, maybe that's persuasive enough, maybe it's not, but at least you got some numbers to talk from, right? And to back it up. So that's one use case. Now, the second use case is after the fact. Okay, maybe the fan's already installed and the system or the balance report comes back and says, hey, this fan's not performing. We can't commission the buildings or short on air, blah, blah, blah. Now, how do we fix it? Okay, so we added some tools in the program here to help you fix it. And you'll notice that some of these numbers down below are in green. And, well, in this case, none are red, but if they were red, that means you're going to make it worse. If you go to a condition that's green, you're going to make it better. So what you do is you would simulate what's my current condition, and then you look down below, and if you go to a green condition, it's going to improve it. Now, naturally, the bigger the magnitude of the green number, the bigger the magnitude of the change, right? So we got lots of opportunities here. Some people come in and say, well, geez, I just want to add some ductwork between my fan and the elbow. So in this case, I added 5 duct diameters worth of straight ductwork. Notice now I'm only over by 14% rather than 23%. That's what, a 9% improvement? That's pretty good. But boy, that's maybe not good enough. So what other options do I have? Well, I could swap out that sharp elbow with a smooth elbow, a couple more percentage points, or maybe I put a 45-degree elbow on it, or maybe I remove the elbow. So I got the ideal inlet condition, but look at it, I'm still short by 3% on the air and 10% on the brake horsepower efficiency, right? So I got some green over here at the outlet. Look at, I could add some outlet ductwork, and now I can finally get back to my rated performance. That would be what you get out of CAPS, what you get out of the catalog, etc., right? So it's kind of a learning tool at the same time, to help guide you towards, getting that right. The first time I saw this, I scratched my head a little bit, and I was like, that's interesting. A blower is intended to have ductwork on the outlet in order to achieve the performance. Now, how many of you have seen blowers, out on the roof, for example, in that upblast configuration, just upblasting directly without any ductwork on it? Well, those fans are probably losing 10% efficiency because they don't have a little short stack on that outlet, right? So that's kind of something interesting. And this is not a Greenheck tool. This is an industry tool. Regardless if it's Greenheck or our competitors, they all, these same rules and math and everything all applies, right? And they tested their fans with ductwork on the outlet as well. So you don't have to take our word for the number. If you come over here underneath assumptions, and what we did is we took one of our fans, and we ran it through the AMCA publication 201. That's the third-party accepted standard for how to calculate system effects. So again, not a Greenheck thing, it's an industry thing. All right, so that's our system effects simulator. That's just one tool in our toolbox that's available. All right, so next what I'd like to do is I'd like to shift gears and I would like to talk about um, our Revit add-in. Okay, now the Revit add-in, once you get it installed, you get lots of tools and lots of power in it. And I'll show you how to get it installed in a moment. But I want you to think about what's your current workflow when you're in Revit and you want to get some manufacturer's content, or I want to make a selection or add some HVAC equipment to my Revit project. I'm going to make a speculation, and each one of you might have a little bit different workflow, but I don't think I'm too far off. Many of you probably are using Revit to drafts, and you'd exit Revit and you'd open up some third-party software like eCAPS or CAPS or some competitor software, or go to someone's website, right? And you'd make a selection in that program or software, and then you would have to find the Revit content and you download it. More often than not, most manufacturers' content are zipped up in a zip file, right? So you have to unzip it. Then you got to store it somewhere, right? So you pick your, desktop or whatever. Then you got to go move it to maybe a shared folder, network drive underneath a job folder or something of that nature. And then now we got to go back to Revit, and now we've got to open up our project, and then we have to go find where we stored it, and then bring it into the Revit project, and then place it on the building. That's a lot of steps, right? A lot of phone calls can happen. You might get interrupted. All sorts of stuff can happen, and maybe your workflow is not exactly that same, but it might be somewhat similar. So think about that as I'm demonstrating this Revit add-in. All right, so I've got Revit 2024. I think I'm running here, but it works with Revit 2020 all the way through Revit 2024. I'm sorry, Revit 2025. And we're looking at adding it to Revit 2026 here shortly. So once you get it installed, we got this Greenheck tab up here in the ribbon, and I'm going to cover all these different buttons, and I'll show you how to get it installed later. The first three buttons I want to focus on are these three over here, and this is how do we get Revit content into my Revit project. The first one I'd like to talk about is select by model, okay? So the use case here is I know exactly what model I'm looking for, okay? So what this does is it links out to a directory, a live directory for that matter, of hundreds of Revit families. Okay, this is basically links out to our website, but you don't have to actually go to the website. It links to it directly. And you can filter on, are we looking for air terminal units or dampers or diffusers or gravity or fans or whatever, right? There's lots of HVAC equipment in there. Or if I know my model name, I can just type it in. Maybe I'm looking for that BSQ. So I go ahead and I click the insert button. I pick my size. I could multi-pick if I want. Let's just go with this one. And what it's doing now is it's grabbing that Revit family. It's bringing into my Revit project. It's picking that size and it's putting it on my cursor. Okay, so then I just simply click and I'm done. So now I've got my first Revit product inserted into there, and you could see how quick that was, right? That was what, 10, 20, 30 seconds, right? So think about your other workflow, how you're doing that today, and how much savings on time that might be. Now, this particular selection that I entered in here is an LOD 200 Revit family. No performance information, no electrical, basically no parameters because we didn't enter in any information. It's just that physical size BSQ 160, I think it was. Okay. All right, so then let's get into the second method, select by performance. The use case here is, well, maybe I don't know that I want a BSQ, much less what size it is. I want to enter in some performance, right? So we click on that, and what that does is it links out to eCAPS. So everything that we've learned before, or maybe already know, applies here as well. It's just we're not leaving Revit, where it's all within Revit. So I'm going to make a fan selection. I'll do a roof exhaust. I'll pick maybe 6,000 CFM at 3/4 of an inch of pressure at sea level. We'll just do 463 phase again. But everything else is the same. Our ranking is the same. Those caution selections are the same. I can filter. I can pick my application if I want restaurant exhaust or whatever, right? Everything's the same. The only difference here is rather than having that little plus sign here for adding it to Excel, we have a little R sign for adding it to Revit. So go ahead and I click on that. And naturally, we got to tag it, right? So this is an exhaust fan, so EF-1. And I can generate a cut sheet here if I want to. It just prompts you to where you want to save a PDF of that cut sheet. Or if I want to download the Revit content rather than inserting it directly, you could do that too. But most people insert it. So what it's doing is it's grabbing that Revit family, it's taking all the parameters that we've got from eCAPS, and it's bringing it into my Revit project, and then it's putting it on my cursor, and I place it, and I'm done. Okay. Now this is an example of our LOD 300. Where we go to our type properties, and you can see we have all of our electrical parameters, and we scroll down, you can see we have all of our mechanical flow parameters, right? Your RPMs, your sound, your brake horsepowers, all that stuff's there. So just, all that information that you would need for scheduling. Okay, and I'll show you how to schedule here in a few moments. But a few other things that I'd like to point out here as well is you might be wondering, well, what's that big blue box around the outside? Okay, that's our service area clearances. Okay, and if you don't want to see those, we've got speed buttons up here in the top where we can turn those off, right? So maybe I don't want to see all my clearances. I can just click the off and then they're all gone, right? Or I could click them all back on, whatever you want. Um, in addition to that, we have mild configuration, and that kind of varies based upon the product. So for example, this one here was a roof mounted fan, right? And a roof mounted fan needs a roof curb typically to be mounted, right? Our roof mounted fans typically don't come with roof curbs, but someone's got to supply one, right? So, you can opt for one, through the Dorse guys, or on our eCAPS side of things, we just provide it. So in this case, you can see we've got a 12-inch tall roof curb in there, but maybe I don't want that roof curb. I can turn it off or back on. Or I can customize it. Maybe I want a 24-inch tall roof curb instead, so we can do that as well, and notice it updated that. Okay, that's what I mean by mild configuration. Okay, in addition to that, the product type changes a little bit. This is an inline fan. Maybe I want to add a filter box, right? So we could do that, and that adds a filter box to it. Or if you're dealing with like a blower type product, I want to change the wheel rotation or the discharge position, you could do that as well. That's what I mean by mild configuration. All right, so
Hey
next thing
Jay,
I'd like, yeah.
quick question. You covered it already. You can change the curb height. How many options, I guess, what kind of height options for that curb height can you change that to?
Well, I don't think we've got any constraints on there. I mean, you can change that to 18 inches, 14 inches. Maybe I want to change it to 4 feet. You can change it to just about anything. It's just a
Okay,
dimension. It's just a dimensional thing. We don't have any constraints on it. It's pretty tough to put constraints within Revit itself.
perfect. Thank you.
Yep. Great question. Okay. All right, so we talked about two of the three different methods for inserting Revit content. The third method is from a previously created eCAPS job. So if you remember correctly, we created that job called test earlier, and I think that had a little QEI on it, right? So we go ahead and we can insert that Revit content as well from that previously created eCAPS job. And again, it just brings it on my cursor. This is a LOD 300 design, and we place it in a building, and away we go. A couple different workflows there. One workflow is maybe you want to make all your selections first and then draft later, kind of like what we just did here. Or maybe you've got one person in your office that does the selections and someone else does the drafting. In that case, you make all your selections in standalone eCAPS, and then you share that Revit project with that drafter. They save it into their Revit account, and then they come in here and then they insert it. They didn't even have to make the selections.
Hey
Okay.
Jay, quick question.
Yeah.
One more question on the roof curb. Can you do a slope on the roof curb?
Yeah, that's a great question. At this point, you cannot. Our 300 content doesn't have that slope option, but if you get out of the CAPS, desktop CAPS program, you can slope it out of there. We have some projects in queue that we want to allow that sloping of roof curb in there. We just haven't done it yet. Great question, though.
Okay. And then one more from Emily. She asked for the filter box, is that specific to type of filter that the fan can come with, or is that a general length?
That's a general length. For the most part, that particular product, the type of filters you put in there doesn't matter from a physical length perspective. The performance may vary quite a bit, but not the length. And again, since we did it on the LOD 200, we never entered in any performance. There was no corrections or nothing to show, so it's just the physical space envelope.
Okay, perfect. Thank you, Jay.
Yeah. All right, so that's how we get Revit content into the Revit project, okay? Now, once we get it in there, there's lots of other things we can do, okay? The next one I want to talk about is scheduling, okay? Scheduling from Revit. So we talked about one technique of scheduling using Excel. I'm going to show you three different techniques for scheduling out of Revit. Now, the first one is the easy button. It's just create a Greenheck schedule using Greenheck parameters. So the pop-up comes up here and we default to the same columns that eCAPS would have, but maybe we want to add an FEI in our schedule, and maybe we want to add, maybe we don't want to have drive type, and maybe we want to add an FEP input power, and we want to move them around or whatever, right? Match your company layout. Once you're done, hit the Create Schedule button, and voila, there's your smart schedule. So as I add more Greenheck fans, they'll just automatically show up in the list. If I delete one, it'll delete it out of the list. Thus, a smart schedule, right? Pretty fast, pretty intuitive, as you can see. I skipped over this, but you can change your column headings if you want to. If we come back, you can come over here and say, well, I don't want to have it manufacturer spelled out. I want to come over here and do, MFG or whatever, right? You could do that as well. Okay. All right. So that's one method for creating a schedule, and that works really well. It's really fast. The downsides to that one are maybe you already have your own schedule created using your own parameters, or maybe you have a mixed bag of manufacturers in your Revit project, or whatever. There might be several different reasons for it. So that comes into the second technique. Now, the second
Well, real
technique,
quick, Jay,
yeah,
quick question. How are you controlling tag numbers when adding or subtracting?
okay. Great question for tags. So as we were inserting it, there's a field there that's tag name, right? And those basically need to be unique, right? That's the tag that comes in there, and that's a parameter. So if you would come in here, for example, notice I've got three fans. Only two of these three fans are LOD 300 content, right? Because this one here, there's no performance, so there's nothing to schedule, right? But let's say that I deleted this tag here out of my list. Now we come back here to the schedule, and you notice that that one's gone. So I'm not sure if that answers the question, but
I think so.
okay.
Richard, you let us know if that answered your question. But yeah, continue. Thank you, Jay.
Yeah, no problem. All right, so we talked about the one method for scheduling, and that's using Greenheck parameters. Now, the second method is what we would call variable mapping. What we can do is we can map our parameters to your parameters. Okay. Underneath this use case, you probably have your own shared parameter file. So what we would do is we're going to create a mapping, and we're going to load your shared parameters file over here. I happen to have one mocked up. I just have a shared parameters file here. And what we're going to do is we're going to take the Greenheck parameter here in the leftmost column, and we're going to map it to one of your shared parameters over here in the third column. So I'm going to pick on BHP. That the BHP is Greenheck's parameter, and we're going to map that to your brake horsepower parameter. So, for example, maybe that little SQ fan had a 3.1 brake horsepower or BHP value in it, right? We're going to take the 3.1 and we're going to put that into your shared parameter of brake horsepower that you'd have in your schedule, for example. Okay, and you do that for whatever parameters you want to map. And when you're done, you hit the apply button, and then away you go. Um, we added some additional tools in here. Maybe you only want to do that once and not have to reinvent the wheel every time you start a new Revit project. So what we could do is we come up here and we could save that, and then we could load that at a later date. Or you could make that a part of your Revit template every time you start a new Revit project. So this is probably the most common way for scheduling, is using this mapping. For those of you that might use Parameter Jammer or some of these other purchased tools that map some of that stuff, this is the same thing, but it's free and it's all built in. Okay, so that's the second technique. Now, the third technique is the opposite of the second technique. Remember, the second technique, we're taking the values from our parameters and putting them into your shared parameters. The third technique is we're going to take your shared parameter and put it into our Revit family. Okay. The use case there is, maybe you have a BIM department that says, hey, you can only use these certain Revit families. And most likely what they did was they took some manufacturer and they just stripped out all the parameters, making it basically an LOD 200 family, right? Which we already have an LOD 200 family over here, right? So what we're going to do is we're going to take and add a user parameter. So this one happened to recognize the fact that we already loaded your shared parameters file. It just recognized it from the previous step. And so the list over here is your shared parameter. I'm going to pick on your brake horsepower and we're going to add it to our BSQ LOD 200 family. Hit the apply button and we're going to take your brake horsepower field and we're going to put it into our family. Not necessarily a smart schedule anymore because someone's got to populate the brake horsepower value. Okay, now there's different solutions for that. I've seen people have an Excel file outside of Revit that they create, and then they import that Excel file into their shared parameters, and then that shared parameter then comes into our Revit family. That's fairly common. It's another method that you can choose, but there's a lot of different buttons that got to be pressed there to do it. That's just a different alternative. Okay, and you can mix and match the second and third techniques if you want as well. All right, so that's how to schedule. Now, the last thing that I wanted to talk about is, 'cause we're almost out of time here, is your jobs probably evolve over time, right? So you probably made this selection here, for example, and we did 6,000 CFM, right? But what happens, hey, I'm expanding this office space or whatever, and now we got to get an extra 300 or 500 CFM out of that fan, or maybe added 2 extra elbows in the system. We got a 1/4 inch more ductwork or whatever your use case is, right? So normally what you do is just hit delete and you'd start all over again. Well, we made it really easy. What we did was we added this reselect button here. And what that does is it remembers all of my original inputs when I made that selection initially. And right now what it's doing is reselecting that one. It's going to remember my volume, my pressure, my application, my voltage pick, my tag name, all that stuff. It's going to remember it and it's going to reselect the same one that I originally picked. Maybe you just want to change sizes because you want it to be a little bit quieter, or maybe you want a little larger ductwork. I don't know, a lot of different use cases, or you get different performance. So this takes about 8 to 10 seconds to do, but basically it's reselecting that same fan. It's going to re-highlight my original selection. And as my baseline, and then from there then I can change it, right? So we had a GB 220, so maybe now I want to enter in 6500 CFM, and so it's going to try to reselect that same GB 220. If it's available, it'll repick it. If it's not, a message will come up saying, well, you got to pick a different fan. Okay, so this takes a few seconds here to run, and so in this case, that original one is no longer available, so we got to pick something else. In this case, the top ranked item, no caution icons. It looks good. If that's what we want, we hit the R button. We can generate a fresh cut sheet here if you want to. If not, we can just reinsert that one. When we reinsert it, a message will come up asking you, or telling you that if you have any other EF1s on your Revit project, it's going to redefine those, right? So if you have, 5 EF1s selected or inserted in your project, it'll update them all. And that's what that message is all about. But now notice that it updated it to the size 300. It updated my Revit schedule to 6500 CFM with the 300 CFM, or the size 300. And if my electrical was connected to a box, it would update that. If my ductwork was connected, it would update that as well. So that's hopefully a neat little tool that helps you. If you're using BIM 360, it works great with all that as well. All right, so how do you get this Revit add-in? Okay, so what you do is you come out here to greenheck.com and you'd come underneath resources, then you'd come underneath software, and underneath software we call this our eCAPS bridge for Revit. You'd click on that, and here's our little download button right here. You click on that and it inserts it. It works with Revit 2020 through Revit 2025. So that's a Revit add-in. We're kind of at that 1 hour threshold here. What did we cover today? We covered the various LODs. Hopefully that was helpful. We covered eCAPS. Hopefully you learned something about eCAPS. If you were already familiar with it, hopefully you've got some tips and tricks out of there. Then we covered the Revit add-in. For those of you that weren't familiar with it, hopefully you got an appetite there for getting that thing installed. And we covered 4 different methods for scheduling, and we also covered our system effects simulator. As far as the Revit add-in is concerned, you'll notice we got lots of other helpful contact and support information and help tools and other things of that nature. So, all right, any questions that we haven't already covered?
Thank you, Jay.
I did
yeah,
put
what do
that
you got,
link in
Chris?
the chat. I would say I did put the link to this page you got right there in the chat for everyone's quick reference.
Excellent.
And we'll stick around for a couple minutes to see if anyone had any questions. We did throw a lot at you guys. Jay, you barely even breathed there. Thank you so much for running through that. It is recorded, so in case you guys wanted to, had questions, we can send you the link to our YouTube channel, and we can go back and review the tape. Like I said, we'll stick around a couple more minutes. We have another. Thank you, Jay, obviously, for doing this. If you guys want an individual presentation, we're more than happy to do that to your individual firms with Jay, myself, Chris, and Scott, and Nick. Next week, we have another power hour on our Ingenia custom air handler series. So if you guys want to tune in for that, that'll be great. That'll be going over application and features from the Ingenia technologies. I don't see any questions coming in. Just a lot of thank yous. You killed it, Jay. Thank you so much. This was a good one. Chris, did you have anything to add or any comment?
No, great as always. Thanks, Jay.
Yeah,
Thanks,
thank you, Jay.
Thank you. Thanks everyone for signing in.
Yeah, I think that'll do it. So hope to see you guys next week for our next Power Hour series on our air handler line. And yeah, until next time.